and happy return to the AI Academy. We will get on with our Business Analytics for Management Decisions course today. We are going to learn more about using Microsoft Excel for business analytics. Excel has many useful functions that can help managers make decisions. This lecture will cover the following topics like basic Excel functions with the help of examples, functions for specific applications, insert function, different logical functions, followed by lookup functions, and will finally conclude with spreadsheet add-ins for business analytics. Let's start today's lecture by discussing on some basic Excel functions. Excel is a powerful tool widely used across various industries for numerous reasons. Its functions are built-in formulas that allow users to perform common mathematical, statistical, and logical operations easily. These functions are fundamental to working with data in Excel and help streamline various data analysis tasks. Below are some key basic Excel functions. Equal to min in bracket, range, is the function that returns the smallest value from a specified range of cells. For example, if we have a range of numbers in cells A1 to A10, entering equal to min, A1 to A10, will give us the smallest number in that range. Next is equal to max in bracket, range, is the function that works in a similar way to the min function, but it returns the largest value from a specified range of cells. So, if we enter equal to max, A1 to A10, it will give us the largest number in that range. Similarly, for sum we have to write equal to sum in bracket, range. As the name suggests, this function adds up all the values in a specified range of cells. For instance, if we have a set of numbers in cells A1 to A10, and if we enter equal to sum in bracket, A1 to A10, it will add up all those numbers and give us the total. Equal to average in bracket, range, is the function that calculates the average, that is, mean, of a given range of numbers. If we enter equal to average, A1 to A10, it will add up all the numbers in that range and divide the sum by the total number of cells, in this case it is 10, giving us the average value. Equal to count in bracket, range. This function counts the number of cells in a specified range that contain numerical values. If we have a range of cells from A1 to A10, and some of those cells are empty or contain text, entering equal to count, A1 to A10, will give you the count of cells that have numerical values. Equal to countif in bracket, range, criteria. This function is a bit more advanced. It counts the number of cells in a specified range that meet a specific condition or criteria. For example, if we enter equal to countif, A1 to A10, greater than 10, it will count the number of cells in the range A1 to A10 that contain a value greater than 10. These functions are essential for performing basic calculations and data analysis in Excel. They can be combined and nested to perform more complex operations, making Excel a powerful tool for handling and analyzing data. Let's understand with the help of example using Excel function. In the figure above, different functions are used to find the minimum value, maximum value, total, and average. We can also count the number of items, either with or without a specific condition. Next is functions for specific applications. Below shown is the mathematical formula used to calculate the net present value in financial analysis. It measures the profitability of an investment by comparing the present value of cash inflows to the present value of cash outflows. This formula directly corresponds to the equal to NPV function in spreadsheet applications like Microsoft Excel or Google Sheets. The formula is NPV equals to the sum from t equals 0 to n of f sub t divided by 1 plus I raised to the power of t, where t represents the time period, ranging from 0 to n, that is, the total number of time periods. The summation symbol indicates that we are summing a series of values from time, t equals 0, to t equals n. Ft represents the cash flow, that is, either inflow or outflow, at time period t. I represents the discount rate or the required rate of return. 1 plus I raised to the power t is the discounting factor used to calculate the present value of the cash flow at time t. This formula calculates the sum of the discounted cash flows for each time period, from t equals 0 to t equals n. The cash flow at each time period of ft is divided by the discounting factor, 1 plus I raised to the power t, which accounts for the time value of money. This process converts the future cash flows to their present values, and it is the sum of all these discounted cash flows. The function in Spreadsheet Applications implements this formula to calculate the net present value of a series of cash flows. Users provide the discount rate and the cash flow values, that is, value 1, value 2, as arguments to the function, which then applies the formula to determine it. A positive net present value indicates that the investment or project is profitable, while a negative net present value suggests that it is not financially viable. The calculation is widely used in capital budgeting, investment analysis, and project evaluation to assess the potential profitability of investments or projects. Or simply to understand, the formula can be broken down as follows. For each time period, t, we take the cash flow, ft. Divide this cash flow by 1 plus I raised to the power t, to discount it to its present value. Sum these present values from t equals 0 to t equals n. Let's take an example to show how to calculate net present value. In the above example, we have calculated net present value using above formula. Here fixed cost is 25,000 and discount rate is taken as 3%. And month taken is from January to June. Let's discuss some more important functions. We will start with insert function. The insert function in spreadsheet software, such as Microsoft Excel, is a powerful tool that allows users to easily find and insert functions into their worksheets. Here is the detailed guide on how to use the insert function, including various ways to access it and its features. Accessing the insert function. First, we have to click the FX button. In the Excel interface, locate the formula bar, which is usually situated above the spreadsheet grid. To the left of the formula bar, there is FX button. Clicking this button will open the Insert Function dialog box. Next is choosing Insert Function from the menu. Alternatively, we can access the Insert Function from the menu. Go to the Formulas tab on the ribbon. In the Formulas tab, click on the Insert Function button, which is typically the first button on the left. Using the Insert Function dialog box. Once the Insert Function dialog box is open, we can utilize its features to find and insert the desired function. Typing a description. There is search bar to type description. For instance, if we need to sum a range of numbers, we can type sum or add numbers. The tool will then suggest relevant functions such as sum. There is selecting a function category. Below the search bar, we find a drop-down menu that categorizes functions into different groups, such as financial, logical, text, date and time, lookup and reference, math and trig, etc. We can select a category to narrow down the list of functions to those relevant to our task. Choosing the function. After typing a description or selecting a category, a list of functions matching our criteria will come into view. When we click on the desired function to see a brief description of what it does. This helps in understanding whether the function fits our needs. Inserting the function. Once we have chosen the appropriate function, we need to click OK. This action will open another dialog box where we can input the arguments required by the function. For example, if we selected the sum function, we will need to specify the range of cells we want to sum. Completing the function. After entering the necessary arguments, we have to press OK again to insert the function into the selected cell. The function will now appear in the formula bar, and Excel will calculate the result based on the provided arguments. Tips for using insert function. Function help. If we need more information about a function, we can click on the Help on this function link in the Insert Function dialog box. This will open a detailed help document explaining the function's syntax, arguments, and examples. Autocomplete feature. While typing a function directly into a cell, Excel's autocomplete feature helps by displaying a list of functions that match the text we have entered. We can select a function from this list to save time. There is formula auditing tools available in the Formulas tab to check for errors and understand the relationships between different cells and formulas in your spreadsheet. Using the insert function feature is a straightforward way to harness the full power of Excel's functions without needing to remember every function's name or syntax. It simplifies the process of creating complex formulas and ensures accuracy in our calculations. Next function we will discuss is logical functions in Excel. Logical functions in spreadsheets like Excel or Google Sheets are used to evaluate conditions and perform actions based on the results. Let's discuss one by one. First we will start with AND. The syntax of AND is equal to, and in bracket we write, condition 1, condition 2. It returns true if all the conditions specified are true. If any of the conditions are false, the entire AND function returns false. It is useful when we want to check if multiple criteria are met simultaneously. For example, equal to AND A1 10, A1 20 will return true if the value in cell A1 is greater than 10 and less than 20. Next we will see OR function. The syntax is equal to, or in bracket we have, condition 1, condition 2. It returns true if at least one of the conditions specified is true. If all the conditions are false, the entire OR function returns false. It is useful when we want to check if at least one criterion out of multiple criteria is met. For example, equal to or A1 equals apple, A1 equals banana, will return true if the value in cell A1 is either apple or banana. Equal to if in bracket we have condition, value if true, value if false. The if function evaluates a condition and returns one value if the condition is true and another value if the condition is false. For example, equal to if A1 10 and less than or equal to 10 will return greater than 10 if the value in cell A1 is greater than 10 and less than or equal to 10 otherwise. Let's take one more example to understand if statement. Equal to if in bracket we have condition, value if true, value if false. Equal to if in bracket we have B4 greater than or equal to 1000, large, small. In this case if quantity is less than 1000 it will show small, else it will display large. Next is nested if functions. They are the powerful tools in spreadsheets, allowing us to make decisions, filter data, and perform calculations based on specific conditions or criteria. They can be combined and nested to create complex logical expressions and automate various tasks. Excel allows us to nest up to 7 if functions within each other, meaning we can replace the value if false part of an if function with another if function. This allows us to create more complex logical conditions. Syntax. If logical underscore test 1 value underscore if underscore true 1, if logical underscore test 2 value underscore if underscore true 2, if logical underscore test 3, value underscore if underscore true 3, value underscore if underscore false. Suppose you have a grading system where the grades are assigned as follows. Score greater than or equal to 90, grade A. Score greater than or equal to 80, grade B. Score greater than or equal to 70, grade C. Score greater than or equal to 60, grade D. Score less than 60, grade F. Formula. Equals if A1 greater than or equal to 90, A, if A1 greater than or equal to 80, B, if A1 greater than or equal to 70, C, if A1 greater than or equal to 60, D, F. If A1 greater than or equal to 90, A, checks if the score is 90 or above. If true, returns A. If A1 greater than or equal to 80, B, if the first condition is false, checks if the score is 80 or above. If true, returns B. If A1 greater than or equal to 70, C. If the second condition is false, checks if the score is 70 or above. If true, returns C. If A1 greater than or equal to 60, D. F. If the third condition is false, checks if the score is 60 or above. If true, returns D. If false, returns F. Let us conclude today's lecture discussing on lookup functions. Lookup functions in spreadsheet applications like Microsoft Excel or Google Sheets are powerful tools for finding and retrieving specific data from a range or table of data. These functions are particularly useful when working with large datasets or when we need to dynamically retrieve values based on certain criteria. Here are the details of some commonly used lookup functions. The VLOOKUP function in Excel is a powerful tool that allows us to search for a value in a specified range of cells and return a corresponding value from the same row or a different column. It stands for vertical lookup. The syntax of the VLOOKUP function is as follows. Equal to VLOOKUP in bracket, lookup underscore value comma table underscore array comma column underscore index number comma, range underscore lookup. Here is what each argument means. Lookup underscore value is the value we want to find in the first column of the table array. Table underscore array is the range of cells that contains the data we want to look up. It should be a contiguous range, with the lookup column being the first column in the range. Column underscore index underscore number is the column number in the table array from which we want to return a value. For example, if we want to return a value from the second column, we have to enter 2. Range underscore lookup, which is optional, is a logical value that specifies whether we want an approximate or exact match. If true or omitted, the VLOOKUP function will find an approximate match, that is, the next largest value that is less than or equal to the lookup underscore value. If false, it will find an exact match. Here is an example to illustrate the usage of VLOOKUP. Suppose we have a table with employee names and their corresponding employee IDs and departments, as shown below. Employee name, employee ID, department. John 101 sales. Salman 102 marketing. Ram 103 IT. Geeta 104 finance. If we want to find the department for the employee with the ID 103, we can use the following formula. Equal to VLOOKUP in bracket there is 103, A2 to C5, 3, false. Here is what each part of the formula means. 103 is the lookup underscore value, that is, the employee ID we want to find. A2 to C5 is the table underscore array, that is, the range of cells containing the data. 3 is the column underscore index underscore number, that is, the third column, which contains the department information. False is the range underscore lookup argument, specifying that we want an exact match. The result of this formula will be IT, which is the department corresponding to the employee with ID 103. Note that the VLOOKUP function searches for the lookup underscore value in the first column of the table underscore array. If the lookup underscore value is not found, the function will return the hashtag n/a error. Additionally, the VLOOKUP function is 0, meaning that the lookup column should be the first column in the table array. If our data is arranged horizontally, we can use the HLOOKUP function instead. Equal to HLOOKUP in bracket, lookup underscore value, table underscore array, row underscore index underscore number, range underscore lookup. The HLOOKUP function is similar to VLOOKUP, but it searches for a value in the first row of a table or range and returns the corresponding value from the specified row. Lookup underscore value is the value we want to look up. Table underscore array is the range or table that contains the data we want to look up. Row underscore index underscore number is the row number in the table underscore array from which you want to retrieve the value. Range underscore lookup is an optional argument that specifies whether you want an approximate or exact match, true for approximate, false for exact. While talking about index, its syntax is equal to index, array, row underscore number, col underscore number. It returns a value or reference from a given array or range. Row underscore number is the row number in the array from which we can retrieve the value. Column underscore number is an optional argument that specifies the column number in the array from which we can retrieve the value. And the syntax of match is equal to match in bracket, lookup underscore value, lookup underscore array, match underscore type. The match function returns the relative position, that is, row or column number, of a value in a range. Lookup underscore value is the value we want to find in the lookup underscore array. It is the range in which we want to find the lookup underscore value. Match underscore type is an optional argument that specifies the type of match we want, 1 for exact match, 0 for approximate match, -1 for exact match but searching from the last value in the lookup underscore array. These lookup functions are commonly used in combination with other functions or formulas to retrieve data based on specific criteria or conditions. For example, we can use VLOOKUP or index or match to retrieve values from a separate data table based on a value in the current worksheet. This can be particularly useful in situations where we need to create dynamic and robust spreadsheet models or reports. When working with lookup functions, it is important to ensure that our data is properly structured and formatted, as these functions can be sensitive to data inconsistencies or errors. Additionally, it is a good practice to use named ranges or structured references to make your formulas more readable and easier to maintain. Spreadsheet add-ins for business analytics. Microsoft Excel, Windows only, provides several add-ins specifically designed for business analytics. These add-ins extend the functionality of Excel and enable users to perform more advanced data analysis and optimization tasks. Here is a detailed explanation of the add-ins mentioned. Analysis Toolpack is a built-in add-in in Excel that provides a collection of statistical and engineering analysis tools. It includes functions and tools for the following: descriptive statistics, that is, mean, median, mode, variance, etc. Sampling and resampling methods. Hypothesis testing, that is, z-test, t-test, f-test, etc. Correlation and covariance analysis. Regression analysis, that is, linear, exponential, logarithmic, etc. Analysis of variance. Fourier analysis. Random number generation. Next is Analysis Toolpack VBA. This add-in provides additional VBA, that is, Visual Basic for applications, functions that complement the Analysis Toolpack. It includes functions for random number generation, statistical distributions, that is, normal, Poisson, Weibull, etc. Matrix operations, optimization and solver functions. The solver add-in is a powerful optimization tool in Excel. It allows us to find the optimal solution to a problem by changing the values of one or more decision variables, subject to certain constraints or limitations. It can be used for various optimization problems, such as resource allocation, portfolio optimization, transportation and logistics problems, production planning, scheduling and timetabling. In addition to Microsoft's built-in add-ins, there is third-party add-ins available from companies like Frontline Systems, which provide more advanced and specialized analytics tools for Excel. Risk Solver Platform, by Frontline Systems, is add-in from Frontline Systems is designed for risk analysis and decision-making under uncertainty. It includes tools for Monte Carlo simulation, sensitivity analysis, scenario analysis, decision tree analysis, optimization under uncertainty. Premium Risk Solver Platform, by Frontline Systems, which is an advanced version of the Risk Solver platform, offering additional capabilities for more complex risk analysis and optimization tasks. Excel Miner, by Frontline Systems, is a data mining and predictive analytics add-in for Excel. It provides tools for classification and regression analysis, clustering and segmentation, association and sequence analysis, time series forecasting, text mining and natural language processing. This add-ins from Microsoft and third-party providers like Frontline Systems significantly enhance Excel's capabilities for business analytics, enabling users to perform advanced statistical analysis, optimization, simulation, and predictive modeling tasks within the familiar Excel environment. In summary, this lecture covered the following topics such as basic Excel functions with the help of examples, functions for specific applications, insert function, different logical functions, followed by lookup functions, and will finally concluded with spreadsheet add-ins for business analytics. We hope you liked this lecture. If you did, please give it thumbs up and subscribe to our channel. Your support means a lot and motivates us to create more educational content on business analytics for management decision-making. In the next lecture we will discuss on knowing Excel spreadsheet operations, examples with Excel functions, knowing break-even analysis on a spreadsheet, key income statement analysis on spreadsheet, knowing loan repayment schedule by Excel spreadsheet. Get ready for the next lecture on business analytics for management decision-making. Thanks for watching, and we will see you next time.